Forward bias.
Forward bias kan?
Forward bias.
Yes, it is a forward bias. All right. So next, so the down part is, Allah, masuk lagi sekejap Mana pergi main ni? Okay. Alright. So the second part yang bawah ni, the down part here is reverse bias kan? Because it is connected with opposite polarity with the voltage source kan? So the graph here, this is the VI characteristic for reverse bias. Okay, so reverse bias. So when you apply too much volt, okay, there will reverse breakdown will happen. So reverse breakdown will cause avalanche effect. Okay, so we have discussed about this effect in the previous class. So next, continue about diode resistance. So diode resistance happens because of these two reasons. Okay, so diode resistance happen because of the existence of the depletion region itself. Okay, when because of the depletion region acts like a barrier, so it's lots of energy needs to be applied, okay, to overcome this barrier. So the bigger the barrier, so the bigger the resistance will be. All right, and the second things, okay, the second reason why there is a resistance in diode, okay, because of the atoms in diode itself, right? Because when you applied, okay, so when you applied external voltage to the PN junction, right? So from the external voltage itself, there will be carrier comes into the PN junction. So the carrier will collide with the atoms inside the PN junction itself. So because of the collision, will cause resistance, all right? Okay, so see here, when charge carriers flow through the diode collides with atoms, they lose energy. Okay, so lose energy and it will forms in terms of heat, and heat ni lah yang kita panggil that we call as resistance, alright? So there are two types of resistance basically, because there are two types of junction, right? We have forward bias junction and we have reverse bias junction. So resistance also, there are going to be two types, which is forward resistance or reverse resistance. Inside the forward resistance, it can be divided into DC or static resistance and also AC or dynamic resistance, where we will look into details about these two. For reverse resistance, we have learned this in previous class. Okay, we have learned this in previous class because so just for you to refresh for you to remember it again. So PN junction, when you apply with opposite polarity of the external voltage, this is positive, right? This is negative, this is negative, this is positive, right? So the barrier, depletion barrier will be bigger, right? The depletion barrier will be bigger. So the resistance here will be bigger. Okay, so that's why we call this also as resistance appear inside here is also we call as reverse resistance. So reverse resistance basically sama je, same as reverse bias punya operation. Just the difference is forward resistance lah, because there are two types, DC and AC. Okay, first of all, for DC or static resistance, so when the DC or static resistance happen, it happens when the circuit, okay, is connected to the DC voltage source. Okay, so DC voltage source ni, DC stand for direct currents, right? Direct current. So it means that the flow, okay, the flow of the currents is only one direction. Okay, only one direction of currents is allowed. So when there's only one direction of the currents flowing, Okay, so the charge flow also same. The flowing of the charge pun sama. Okay, the flow of the charge also same. Okay, and it will not change by time. Okay, it will not change by time. So that's why we call this the resistance, yeah, as static resistance. Okay, sebab tu kita panggil dia as static resistance because it will not change by time. Okay, so the formula for static resistance is this way, at point Q, for example. Okay, at point Q. So to find the resistance at point Q, you have the information for the V at point Q and I at point Q. So to find the resistance is V divided by I. So at any time, okay, if you applied with V voltage, okay, at point Q, the resistance is always the same. Okay, tak kira lah bahasa tu berubah if the time changing, okay, the resistance value will remain the same, okay, because you applied a specific voltage value. All right. Okay, up until now it's okay. Faham kan until here? Is it okay up until now? For DC. Okay kan? Okay. So kalau DC dah okay, so the questions that might be appear in your test or in your exam might be like this, right? But it will not straightforward like this lah. But this is how the question will ask you. All right. So if they ask you to find the resistance at 2 milliampere currents, so you need to use the graph. You need to find at 2 milliampere current what is the value of the voltage, and then using the value of the voltage at 2 milliampere currents, you can find the resistance value. So you just directly divide. Okay. So I think we have done this example in previous class. Right? So next, let's look at the AC, or we called it as dynamic resistance. So first of all, when we said AC, so you should know that AC is alternating current. So it means that the current is flowing at both direction. Okay, it can flow at both direction, at this direction and at this direction. Okay, so when current is flow at both direction, it means that the current direction can change by time. So at T time, the current might be flow at this direction. And if you change at T2, the current might be flow at this direction. So the flowing of the currents, it depends on what time it is, right? Okay, so that's why the charge also, the charge also will be different according to the time. Okay, so the diode operating time will change as time changes, right? This is not static resistance, sorry, dynamic. Okay, so dynamic resistance is the value of voltage change across the diodes. Ke sama? Tak sama. Okay. So in your notes, Nani, please correct it. Yeah. So this is dynamic. Dynamic resistance is the value of voltage change across the diode to current change through the diode operating point. So how to find the resistance value? Since that the diode operating time change according to time, so if you want to find the resistance at point Q, what you need to do is you cannot directly take the voltage value at point Q because it might change by time, since that this graph is not a time graph. Okay, it is not a time graph. So what you need to do is you need to take 1 point above from point Q and 1 point lower than point Q. Okay, so you take the difference value of voltage and also the difference value of current. Okay, and you need to divide the voltage difference with the current difference. Then only you will get the resistance value at point Q. All right? Is that clear? So, for example, for this questions, for 2 milliamperes currents, right? So 2 milliamperes current is at this point. Okay, so you can't directly take 0.7 volts value. What you need to do is you need to take 1 point above than 0.7 and and 1 point lower than 0.7. So in this case, what did I do is I take 1 point bigger, okay, which is at 0.76 volt, and minus with here at 0 ampere, 0 milliampere voltage, which is around 0.65, yeah, 0.65 volts, and divide with at 0.76 voltage ampere value minus 0 milliampere value. So divide by these two, you will get resistance at point Q is 27.5 ohm. So usually resistance for AC, resistance value for AC or dynamic resistance, it is not accurate. It is not very accurate compared to static resistance or DC resistance. Okay, so 27.5 is just value approximately. Okay, and usually we do like this. Okay, approximately 27.5 because it is not too accurate. Okay, because when you look at this graph also, especially at 0 voltage, right? So 0 volt, especially at 0 milliampere, the reading is around 0.65. So this is might not very accurate since that the graph here is very small. If it is good, much more detailed, for example, around microampere, then you will see that the point here might be at 0.65, might be there is a reading of voltage, current flow, maybe around 0.1 milliampere, something like that, right? So resistance, AC resistance, it is not as accurate as DC, but it is just an approximately reading lah, okay, for the resistance. So for this is reverse resistance. Okay, reverse resistance. Reverse resistance is the resistance offered by PN junction when it is reverse bias. So at reverse bias voltage, the width of depletion region increases and make the amount of electric current blocked by the depletion region will be larger. Okay, and because of that, the reverse bias diode offer large resistance to the electric current, and usually the value is around mega ohm in reverse resistance, right? So reverse resistance is very easy lah. Once you understand what is reverse bias junction, so you will understand the reverse resistance operation too. Okay. So this is just basically a picture. So basically about diode resistance, any questions before we go to the circuit? Before we go to the circuit analysis?
Sensei.
Yeah.
For the dynamic resistance.
Dynamic resistance. Okay.
We want to calculate. We need to take a point above and a point below, right?
Dynamic, yes.
Macam kita tahu nak ambil berapa tinggi?
You can just choose any points that you can dapat bacaan dia yang sangat senang. Faham tak? Okay, for example, don't take point yang reading dia, reading of the voltage ataupun dia punya current, but susah nak baca. Take the point yang reading atau reading dia punya voltage or current dia tu senang nak baca. For example, macam ni kan? Macam ni. Macam ni kan? you make apa ni garis macam ni, and then take point yang dia punya current value dia and dia punya dia punya voltage value yang mudah nak baca. You can also take macam ni, boleh panjangkan lagi and take bacaan dekat sini and dekat sini. It depends. So jawapan usually answer for AC resistance ni dia boleh jadi dia ada range dia. There is a range. Dia ada range. So jawapan dia mungkin dalam 26 ke 28 ohm. So within this range, your answer is correct. Okay tak Go? Go ya yang tanya.
Okay.
So it's just like you learn your maths before. Yang kita kena ambil untuk cari kecerunan and you just take from any points. Yeah. But according to the graph lah, tak boleh you create sendiri your point. The reading must be from the graph. Okay?
Okay.
Alright.
Then for the static resistance, the example C is negative voltage, means that it is reverse bias, right?
Yes. Negative voltage refers to reverse bias. Betul.
Okay. Thank you.
Alright.
Sensei.
Sensei, saya ada soalan lagi. Yang untuk ni dynamic resistance ni kan kita kena extrapolate ke macam tu kan, kita buat line tu kan. Jadi gradient dia tu tak kisah ke?
Macam mana? Again.
Gradient untuk line yang kita akan buat ni.
Gradient untuk line yang kita akan buat nanti.
Dia macam mana kita nak agak
Macam mana kita nak agak? You ingat tak macam masa kita learn maths dulu, when we learn our maths, if you want to make gradient, you should make sure it is of course straight line kan, mestilah straight line kan, tapi it is best if the point ni touch to the line, and then macam contoh I take another example. Contoh macam kita buat kat sini at point ni. So if you want to make a straight line, macam mana nak buat susah ni nak buat. Okay, make straight line, yang line ni touch point yang kita nak dia reading dia punya resistance tu. So make sure yang dia tak lebih daripada point ni lah. Faham ke? So janganlah buat point dia macam ni pula. Janganlah buat point dia macam tu pula. So usually dia punya macam ni je. Kalau point dekat sini, dia akan jadi macam ni. Dia akan jadi macam ni. Susah sikit nak buat ni. Ataupun dia boleh jadi macam ni. Macam masa kita belajar maths dulu, when kita belajar at maths I remember dah. Okay, kita ada belajar kan macam mana nak cari gradient for each line. So it's same concept. Okay, so usually tak adalah soalan akan tanya at point yang very hard for you to choose the gradient. Usually soalan mesti akan tanya point around this point, at this point, at this point, at this point, or at this point. It's very rare for the questions to ask at this point, because kat sini, kalau kat sini pun I think it's very easy. You can just make the line from here to here. Turun bawah macam tu. Okay, sebab itulah that's why examiner usually bila kita tengok jawapan tu, we will make sure at point what you ambil bacaan tu. So usually kalau in real test try to make the line so that examiner tahu, cikgu tahu which one point yang you ambil untuk your reading. Because the main point is for this one, the main thing that we want to test you is your reading correct or not? Bacaan yang you ambil tu betul ataupun tidak. So when you take the reading or point tu betul and you bahagi dengan point yang betul, so basically jawapan you betul lah. So that's why for AC resistance ni dia ada satu large range jawapan dia. dia bukannya specific 27.5. It can be vary. Ada yang 28.5, ada yang 30, ada yang 25. So usually kita bagi range jawapan ni within 25 to 30. So it's free for you to take to make the line macam mana pun. Macam ni ke? Macam ni ke? Macam ni ke? Okay? Is that okay? Confusing sikit kan macam mana nak ambil dia punya line kan. Perpendicular. Kena tangent, betul. Kita kena ambil tangent. Betul. That's the word, tangent. Thank you Daniel, that's the word. Untuk cari gradient tu kita kena pakai tangent. Okay, alright. So shall we go next? Next is about series and parallel circuit. So series and parallel circuit ni just your refreshment kan. What is series, what is parallel? So in series circuit usually the voltage is you need to plus kan, V1 plus V2 V3 you will get V in voltage. But for parallel value for this voltage is same with V in, sama. But for current the current for series is always same, but for parallel the current you need to plus I1, I2, I3 same. For resistance also is different with the series kan. Parallel it is 1 over R1, 1 over R2, and the final answer is also you need to make sure that Req equals to what? Okay, you cannot leave your answer 1 over Req macam ni. So your answer is wrong lah, or you will not get full marks, right? So in series, one component burns, the current becomes inactive. Okay, so if this component burns, so the circuit become open circuit. But for parallel, if one component burns, for example, R2 burns, R1 and R3 still can works. Okay, so that is the advantage of parallel current. Okay, next. Let's look into detail diode circuit analysis in series configuration. So for forward bias, okay, forward bias, positive and negative and negative, all right. So how to calculate the value of VR, the value of VR here. Okay, assuming that this is an ideal diode. So when ideal diode, what is the meaning of ideal diode? Ideal diode, VD ni, there is no potential barrier. Okay, barrier potential ataupun potential barrier is not taken into account. So the VF is equals to 0. For practical diode, barrier potential is taken into account. So it means that the value of VF ni is 0.7 or 0.3 based on what of this diode is made of. Okay, so let's look. Okay, so in this case, it is taking a practical model, not a ideal model. So in using a practical model, okay, resistance of this diode is 0. Resistance of this diode is 0. Okay, practical dengan ideal ni, both of in these cases, both kita tak ambil into account the resistance of this diode. Okay, only in complete diode we take into account the value of resistance in this diode. Alright. Okay, so using the practical model diode, assume that the resistance inside this diode is 0 and VD is either silicon 0.7 or germanium 0.3. So it means that voltage source should be bigger than V voltage. So diode is holding a voltage of 0.7 volt for silicon or 0.3 volts for germanium. So using the Kirchhoff voltage law or KVL, E here, okay, to get the E here is equal with VD plus VR. Okay, VD plus VR, which is VD ni If it is a silicon case, so it is 0.7. Okay, so let's say that E here is 1 volt. 1 volt. So VR is how many? VR is 0.3 volts. Okay, but if if it is not given to you the value of value of usually this value is given, right? So no lah. Okay, usually this value is given, so no lah. So and then another thing that you have to remember is ID kan. The currents that flow in this diode is same with current that flow in this resistance. So ID equals to IR. So according to Ohm's law, VR is equals to IR, R, and IDR. Okay, so to calculate VR, either you need you want to know how much the currents, or you also can use the Kirchhoff voltage law. Okay, you can use this two formula, either Kirchhoff voltage law or Ohm's law. Okay, so if you want to use Ohm's law, you need to know the value of current. But if you want to know if you want to use Kirchhoff voltage law, you need to know the value of the external source and also the value of this diode. Okay, so let's look into another example. Any reverse bias model first. For reverse bias diode, okay, so the current flow usually 0, right? Because we assume that in ideal or practical, okay, there is no current flow inside the diode in reverse bias condition, because the barrier potential is very big. Right? So the current flow is approximately 0 ampere. So ID is equals to 0 ampere. So using the Kirchhoff voltage law, okay, E is equals to minus VD. This is because of the diode is working under reverse bias condition. Okay, that's why it is minus. So E equals to minus VD plus VR. So E equals to minus VD plus VR is equals also IDR, right? IDR. So since that ID is 0, so it means that E, in other words, we can also write E equals to minus VD. Okay, right, so this is the configuration of the for this circuit. Okay, next, this is the example for forward bias. Try to find VD, VR, and IR in the circuit below. So the external source is 3 volts, and given that the diodes is silicon, so silicon, it means that the voltage is 0.7. So in order for you to find VD, I think VD directly you can find when you know that the diode is made of silicons, right? So VD is 0.7, right? 0.7. So VD directly you can find from the information what the diode is made of. Okay, if it is made of germanium, so it means that the VD is 0.3. So once you know VD, you can directly or definitely you can find VR by minus, right? 3 minus 0.7. So you will get VR is 2.3 volts. Okay, so when you know VD, you know VR, you can find IR. Right? So using Ohm's law, IR is V divided by R. So 2.3 volts divided by the resistance value, which is 2 kilo ohm. You will get the value of IR is 1.15 milliampere. So it's very direct, right? Okay, next, let's look another example, which is reverse bias example. So same, you need to find VD, VR, and IR. So what is the value of VD?
Zero point 0.7.
0.7. But we have to make sure yang No. No, VD is not 0.7 because it is a reverse bias, kan?
Negative 0.7.
No. Kan tadi, did you remember about this one? In a reverse bias, kan? E
-3.
akan sama dengan minus VP, kan? So in this case, for reverse bias, betul, who said this now?
-3.
So the value of VD for reverse bias, E is equals to negative VD, so it is negative 3 volts. Okay? So it is open circuit, kan? If it is a reverse bias, it means that currents cannot flow, and the currents cannot flow inside the voltage, inside the diode also. So that's why patutnya 0.7, but then since current cannot flow inside this, so it means that the value of VD, it will take the external source value, which is minus 3 volts. Minus 3 volts ni, minus ni because it is reverse bias lah. Alright. So next, what is the value of VR? So since that there is no current flow, IR 0, so VR also 0. Okay, so for reverse bias, it's very easy lah. So since that there is no current flow, so it means that everything will be, for this value will be 0. Okay, so next, let's look for this one, where there is a silicon and there is also germanium. So first of all, you need to identify first, this is forward bias or reverse bias of the diode. So this is forward bias or reverse bias, which one? Forward kan? Kalau kita draw into symbolize like this, so you can see that this positive is connected to this positive, right? And this positive also connected to this positive too. So it means that currents can flow inside this. So it is not open circuit, it is closed circuit. So what is the VR value? So this is 0.7, this is 0.3. So 12 equals to 0.7 plus 0.3 plus VR. So you will get VR sama juga dengan 11 volts, okay? Minus this one, right? Okay, so once you get VR 11 volts, you can definitely find IR by dividing with the resistance value, which is 5.6 kilo ohm. So you will get the value of IR that flow inside this resistor is 1.96 milliampere. Okay, so it's very easy, okay? Straightforward. Right, for this one, this is negative. So negative. This is also forward bias, kan? Negative. So the currents can flow inside this. So it means at V01, what is the value of the current voltage here is minus 10 equals to, this one is 0.7 plus 0.3. So it means that 1.0 plus here, kan? Plus V01, plus V01. So you will get V01 is minus 10. Oh, sorry, I forgot to put minus here. Minus here, sebab dia minus, kan? So minus 1.0, so it will be minus 9 volts, okay? Minus 9 volts. So at VO2, after voltage flow under the resistance, the value will be lesser, kan? So what you need to do is, you need to find the current value first, kan? So at minus 9 volts ni, divide with, you need to find the resistance here. 1.2 kilo ohm first. You will get how many? Minus 9. Today I think we need lots of exercise. We will do lots of exercise. 1.2, you will get minus 7.5 milliampere. So the current that flow here is minus 7.5 milliampere. Betul ke? Voltage current IP equals to IR. So here, from here, you can find the value of voltage flow here. Time with 3.3. 3 equals to IR. Betul ke? Is it correct? Did I do? 9 divided by 1.2. Did you do? How much did you get?
Negative 7.5 milliampere.
Negative 7.5.
Negative 7.5 milliampere.
Alright, so how much? Okay, so sama lah negative 7.5 milliampere. Alright, so at VO2, how much is the voltage flow here? This is, what did I do? What did I do? Sekejap ni. So VO1, so VO2 is, sekejap ni. Kejap. In this case, I think the special scale.
Doctor,
Yeah.
how about use the 10 volt divide by the resistance, the total resistance, and you get the current. Get the current and then times the resistance separately.
How much did you get the answer?
I think it's 7.33 for VO2 and then 9 for VO1.
7.33. And what is the value of the currents?
The current is I just use 10 divided by 4,500. The current is 0.00222 ampere. And then use the current to multiply back the resistance one.
Use the current to apply by the resistance. How much did you
To
get?
multiply.
Tambah 0.7. Okay. I think this answer is wrong for VO2 ni. VO2 the answer is wrong. It is not minus 6.6, right?
Yes.
Kan? Bukan.
Saya setuju, Doktor.
Sorry. So this answer is wrong. What did your answer did you get? Around 7 something, betul tak? Kejap so voltage here is how many? This is 0.7. No, sorry, this is 0.3. This is 0.7, right? So this is 1. So the total voltage should be 10, kan? So here is minus 9. So I think VO1 also wrong then in this case because contoh current dah tak flow lah tu dekat sini. Soalan yang betul ke? Contoh mata Yeah, I check the question first. Why did I take this question? I got this from the previous notes that has been given to me. Kejap eh. Kejap. Where is it? Mana ni? Kejap wait a minute. I need to confirm it first for these questions. Okay. Ah, I see. I see. Wait, yeah. The real question is, sorry, there's a mistake in this question. Okay, for this question, I stop presenting. Present, make the speaker first. Slide show first, and then try present window. This window, share. Okay, for this question, there's actually, sorry, it's my mistake. Okay, there is no silicon here. Sorry. There is no silicon here, so it means that at VO1, this is 0.3 kan? 0.3, so minus 10 minus 0.3 at VO1 is 0. 0. Oh, kita tak boleh cari lagi. There's no silicon here first. First of all, you need to find the total resistance here first. 1.2K plus 3.3K. So the answer is how many? 4.5K. So 4.5K. So that is the total resistance kan? 4.5K. So V is minus 10. Yes?
The GE diode don't have resistance ke?
No, we assume that this is an ideal. Bukan not ideal. Practical diode. So it means that we don't consider the resistance inside this diode, unless kalau it's mentioned that we need to consider it is a complete diode. Then only they will give you the value inside this resistance. The value resistance inside this diode. Sorry. I'm saying. Okay, so is that okay? So you need to make sure which condition of this diode first of all. So the resistance value is 4.5K, right? So V equals to IR. So the voltage is 10, right? So the voltage is 10. So the flow of currents is always the same, right? So let's say 10 minus 0.3 first, right? Okay, 10 minus 0.3, I divide by R. Okay, I divide by R. So R is 4.5K, okay? 4.5K. So the value of I is 10, 0.7, 9.7 divided by 4.5 kilo ohm. So it will gives you 9.7 divided by 4.5 kilo ohms, which is 4,500. It will give you around 2.156 milliampere. Charging. Charge. Okay, 2.15 milliampere. So the currents that flow inside this is 2.15 milliampere. So if you want to calculate the voltage at this condition, yeah, VO1 sama juga dengan 2.15 times 1.2 kilo ohm. So you will get 2.15 times 2.15 milliampere. Sorry, 2.15 milliampere, 0.02. Betul tak? 0.0. 10 to the power of minus 3 times with 1.2 kilo ohm. You will get the value of here is 2.58. Okay, for VO1. And there is no actually VO2. Yang ni adalah I. This is the value of currents. So value of current is 2.15 milliampere. Is that okay? Oh, salah kat mana? Sorry. Please correct your notes, yeah. The one that I give to you. The one that I give to you. This is I actually. There is no V there. Okay. And the answer also here is wrong. Alright. So okay, so let's try another one. This one, there is a RD. Where is the resistance inside the diode? Okay, so first of all, for this thing, let's consider for three kinds of condition. First is the ideal model. Next is the complete model. Next is the practical model, and other is complete model. Okay, so for this, first of all, let's look about the ideal model. So ideal model, as I said just now, we don't consider the value of the diode itself. Okay, so VF is equals to 0 volts. Okay, so IF, if you want to measure IF is the current that flow inside this circuit, right? Because this is a series circuit, so the value of IF is always same at any point. Okay, so IF is equals to V bias, which is 10 ohm, since that there is no voltage of diode in this circuit. So it means that 10 ohm divided by R limit, okay, the load resistance value, which is 1 kilo ohm. So you will get IF value is 10 milliampere. So if you want to calculate the voltage for resistance is 10 milliampere times with 1.0 kilo ohm. So you will get 10 volts, right? I think for ideal model it's very easy because you not consider at all the diode here. You assume that there is no diode here. But for practical model, this one, right? For practical model, you have to consider the diodes here. So if you want to calculate the IF, the current flow inside this circuit, it is V bias minus with diode voltage. Okay, diode drops, kita panggil. So 10 minus 0.7, all right, divide by 1.0 kilo ohm. So the value of currents is 9.3 milliampere. Okay, so if you want to calculate the voltage for this resistance, okay, so this value, the current value, you times with the resistance value, so you will get the value of voltage for resistance is 9.3 volts. Okay, so next let's look for the complete model. Okay, this one someone asked just now, right? If we want to consider the resistance value. So how if you want to consider the resistance value? So first of all, V bias minus VF. Okay, so V bias minus dengan V drops from the diodes. So 10 volt minus 0.7 volts divide with R from the resistance and also R from the diode. Okay, so R from the resistance is 1 kilo ohm plus 10 ohm. So usually the diode resistance is very small, okay, compared to the resistor that we applied directly to the circuit. So 1 kilo ohm plus 10 ohm. So divide by with the voltage value just now, you will get 9.21 milliampere. So if you want to find the VF value, now it is different. Okay, VF value. So VF value is 0.7 voltage, which is the barrier. Kan, 0.7 voltage ni adalah dia punya value, barrier potential value, right? So 0.7 volts plus IF that you find just now, 9.21 times with the resistance inside this diode. Okay, so you add together, you will get the VF value. Okay, for voltage across the diode is, you will get 792 millivolts. Okay, 792 millivolts. Next, if you want to consider, if you want to calculate the voltage of the resistance, then you need to times the current value with the resistance value, then you will get 9.21 volts. Okay, is this okay? I think for complete model, it's quite complicated. So you have to remember. For practical and ideal, I think it's very straightforward. Oh, di mana baca message? Okay. Okay. Okay tak? For this one, complete model, is it okay? For this, this is an example for complete model. Any question?
Still trying to digest.
Okay, for which part? Which part you confusing?
No. I'm still trying
Oh,
to
okay. Oh,
digest.
still digest. Okay. Alright. Okay. It's not confusing, tapi still trying to digest. Okay, so for this part, for this complete model, what you have to memorize is, if you want to find the VF, okay, forward voltage, ataupun kita panggil usually forward voltage lah, voltage across this diode, forward voltage, since that this is the forward bias diode. Okay, so if you want to find the forward voltage, you should add the barrier potential value plus with the current value times with the resistance inside the diode's value. So plus with the potential barrier value, then only you will get the forward voltage value. All right. So you cannot just directly times. Sometimes, what they do is some of you, just directly times 9.21 with the resistance value 10 ohm. So it's wrong because you are not considering the barrier potential value. Okay.
Sensei,
Mm-hmm.
how do we know that VF is 0.7 volt?
It will mention. It will mention inside.
I see.
It will mention to you.
Okay.
Usually, during the in the question, they will mention to you the diode is made from what. Okay. In this question, the diode is made from silicon 0.7. It is not written here. Okay. So it is actually made from silicon. It's very rare the diode is made from germanium. Usually it is from silicon. Okay, so remember, for ideal model, we don't assume the barrier potential value. Okay, we assume that the barrier potential value is 0. Okay, for practical model, we will take into account the barrier potential value, which is 0.7. but we will not taken into account the resistance value. For complete model, we will take into account everything, the resistance of the diode and also the barrier potential too. Okay, so this one you have to remember. So when you want to solve equations, yeah, make sure it is in what condition first. It is ideal model, practical model, or complete model. Okay, identify what condition of the diode first, and then after that, identify if the diode is forward bias or reverse bias. Because if it is a reverse bias, currents cannot flow inside this. So it means that the value V bias, in this case, V bias will same with VF minus. Okay, if it is in a reverse bias condition. Okay, so no current IF will be 0, right? So after you consider the diode is in a reverse or in a forward bias, then only you can solve the the problem, right? So don't just directly solve the problem without identify what is the model first and also the configuration of the diode. It is in a forward or it is in a reverse. Okay, so that is 2 tips that you need to know. Okay. All right, next. Okay, for this one, okay, determine the reverse voltage. Okay, now this question, this question, this is positive minus this is minus, right? Minus this is positive. So determine the reverse voltage, voltage across limiting resistor, and value of reverse current in this circuit. So now you need to know this diode is in what condition? Reverse or forward? It is reverse, right? Because the polarity is opposite, right? So in this case, yeah, in ideal model, okay, I that flow inside here is 0. So when IR is 0, no currents flowing inside this circuit, it means that VR, okay, VR is equal, VR here, VR is equals to V bias, which is minus 10 volts, okay. V here, same with V here, which is minus 10 volt because it is in a reverse condition. And V at the resistor, load resistor here, is 0 volt because there is no current flow at all. So this is an ideal model. Ideal model is very easy. So let's look at practical model. So for practical model, IR, okay, IR is 0 volt, okay, 0 volt. VR is equals to V bias also minus 10 volts. Okay, and VR limit also 0 volt. So ideal and practical sama je untuk reverse diode condition. But for complete model, okay, for complete model, IR is equals to 1 microampere because there is a reverse current given here. Okay, so it means that IR is equals to 1 microampere. It is given. VR limit, okay, VR limit, which is VR limit is here. VR limit is equals to IR R limit. So IR 1 microampere times with 1 kilo ohm. So one IR ni is a reverse current. Reverse current. So usually it is also known as dark current. If you still remember, it is known as dark current because during reverse condition, there is still, okay, even though all the charges attracted to the terminal kan and makes the potential value potential barrier value becomes bigger, there is still, okay, inside here there is still charges flowing which is very low that we call dark current. So this is the value of dark current, 1 microampere. So VR now is no longer 0, but it is 1 microampere times 1 kilo ohm. So it gives you the voltage value is 1 millivolts. So if you want to calculate the V reverse at this diode condition, so V bias minus VR limit is minus 10 volts plus 1 millivolts. It will give you minus 9.999 volt. Okay. Ni Yaya Koshi sikit lah. Dia complicated sikit for this part. So you have to remember this. For complete model in reverse bias condition, you need to take into account the value of dark current. Okay, usually value of dark current will be given according to together with the questions. Okay, but you have to make sure that you need to consider in your calculation in complete model. Right, pening tak?
Pening juga, Doktor.
But did I give this into your notes? I give this to your notes.
Sorry?
Did
Dalam
I-
notes?
In your notes, is it?
No,
No.
Jawapan
but-
tak ada.
kena salin.
Oh, okay. So sempat salin tak?
Sempat.
Okay. Sempat. Okay. So this part is sempat.
But just nak tanya, Doktor. Kita post dekat e-learning by today ke? This recording?
Yeah, I will post the recording by today after the class.
Thank
Okay.
you.
Tak habis lagi. Okay. Alright, next. Dah pukul 1. Alamak, wait. Next, this is LED kan? For LED, so for this, it is connected to the voltage source in figure A. So can you guess the LED is light up or not in this condition? It is light up kan? Because it is positive and positive, so it means that current is flow. Sama saja like the diode itself. So it means the circuit is complete circuit. However, if it is opposite way, the other round, the LED is not light up because of there is no current flow inside this circuit. Okay. So next, still we don't have enough time. This is the answer for the next example, which I think I didn't include inside your handout, right? I didn't include inside your handout, right?
Yep.
Yeah,
Yes.
so we don't have enough time. So how it gonna be? Okay, I will explain this one first, parallel. After this, I will put the answer inside the e-learning. Okay? Inside the e-learning for you to for your reference lah, because we have lots of exercise after this. So I will give the answer inside the e-learning. So I just explained for parallel. For parallel, the currents, okay, the currents flow is divided, right? This is the main current. This is the main current. This is the main current, and the main current now is divided into two, which is ID1 and ID2. Okay, ID1 and ID2. So in this situation, what you need to do first is you need to find the value of I1 first. So to find the value of I1, you have to know the voltage value. So the voltage value is 10 minus 0.7, since that the VF diode is given, right? So 10 minus 0.7. Okay, since that this is parallel, so the value of the voltage is same, right? So E10 just minus 0.7 and divided with the value of the resistor, which is 0.33 kilo ohms. So you will get the I1 value, 28 milliampere. So in order for you to find the next current value, which is ID1 and ID2, what you need to do is you just need to divide these two currents. Since why you just need to divide? Because the diode is same, there is no resistor at all. Okay, kalau if there is a resistor here, so you cannot divide, you need to consider the value of the resistor here. Okay, but since there is no resistor here, so the total current value you can divide two, because it's split into two conditions. So you will take the answer will be 14 milliampere. Okay, and in this case, teruknya dia punya ni resolution. So in this case, for ideal model, okay, since that the question asks the diode is ideal, so it means that VF is 0. We don't consider at all the diode drops for this diode. So the VF is 0. So for you to measure the currents that flow inside here, okay, this is I1, and then this is I3, and this is I2. So I1 is equals to I3 plus I2, right? So first of all, you need to find I1, right? So I1 is 30, okay, 30 divide by the resistor value, and you will get I1. So, and then this I, okay, in this case, since that the diode is ideal, it means that there is no resistance and there is also no barrier potential inside the diode, right? So it assumes that the diode is not exist at all at this part, because we don't consider pun dia punya VF is 0 and the resistance also 0. Okay, so it means that there is no diode here. So it means that the current flow here can be divided into 2. Okay, so 30 milliampere divided by 2, it will give you 15 milliampere. Okay, so this is for parallel configuration. Okay, any question? Faham tak for this circuit? But if it is mentioned the diode is complete or the diode is practical, then you have to consider the value of the barrier potential in a practical condition. In complete condition, you need to consider to the resistance value for this diode. So you cannot divide the currents into 2 easily like this, right? Okay, boleh? Understand? So maybe after this, you can try by your own first. This one, this exercise, this practice first. Which one is forward bias and which one is reverse bias, and then you can check with the answer later on that I will give in e-learning. And also for this one, calculate the current through ID2 and output voltage for VO. Okay, maybe you can try first by yourself, and then you can compare with the answer that I will give inside the e-learning. Is that okay? Together with the recording too, I will give inside the e-learning. Any questions? Any question that you want to ask? Kalau tak faham, if you don't understand anything, you can just ask me, and you can also email me anytime. All right. So if there is no questions, then I will end this class up until here, and I will post the answer for the practice after this, yeah, and also together with the recording. So for tomorrow we will continue until the new chapter, which is chapter 3. So after we finish the chapter 3, we will proceed into the quiz before we go to the test. Is that okay? All right. So assalamualaikum and thank you.
Thank you, Doctor.
Thank you so much.
Thank you, Doctor. Thank you, Doctor.